So we're looking at two special triangles, the 30, 60, 90 triangle and this little isosceles triangle here, where two angles are obviously 45 degrees, and of course there's a right angle. First of all, let's look at this one, a 30, 60, 90 triangle. And the interesting thing with this one is that whatever the length of that side there, that's the short side opposite the 30-degree angle, whatever the size of that one, this one is exactly double it. So if that was 4 centimeters, this one will be 8. If that's 10, this will be 20. It's worth trying to remember the hypotenuse is double the length of the side opposite the 30 degrees. But we're going to call it 1. We're going to say it's got a length of 1. Now you can see that's not 1 centimeter. We're just giving it the unit value 1. So if that's 1, then that one has to be 2. And this one, it would be nice if it was 3, but of course it can't be because it has to be shorter than that one. But actually it's the square root of 3. So learn this triangle. 30, 60, 90, 1, 2, root 3. 30, 60, 90, 1, 2, root 3. Now the reason you need to know it is that you might be asked in a non-calculator paper to find the size of sine 30 degrees. And you would be able to think, well, I know what that triangle looks like. It's the 1, 2, root 3 triangle, 30, 60, 90. So sine 30 is obviously opposite over hypotenuse. So it's a half. Cos 30 is adjacent over hypotenuse. So it's root 3 over 2. And tan 30 is opposite over adjacent, so it's 1 over root 3. Now, some people like to tidy that one up by multiplying the top and the bottom by root 3. This is called rationalizing the denominator. We're making the denominator into a rational number. So looking at the top, 1 times root 3 is root 3. And at the bottom, root 3 times root 3 is, of course, 3. The square root of 3 times the square root of 3 has to be 3. So we have rationalized the denominator and found that. So these 3 angles you need to know. But if you don't know them, if you can remember that triangle, it's so easy to work them out. So look at the triangle again, 30, 60, 90, 1, 2, root 3. Now if you look at the 60-degree angle, sine 60 is opposite. That now is the opposite. That's still the hypotenuse, of course. So sine 60 is root 3 over 2. Cos 60 is the adjacent over the hypotenuse, so that's 1 over 2. And tan 60 degrees is root 3 over 1, which is, of course, simply root 3. So we've used that triangle to find these really important values. You need to know these values, but rather than trying to remember them all, just try and remember the triangle and then how to find them. Now let's look at this triangle. You can see it's a right angled triangle again. It's an isosceles triangle because those two sides have to be the same. So if we give them a value of 1, both of those are 1, you would know from Pythagoras, h squared is going to be 1 squared plus 1 squared. So that's 1 plus 1, which is 2. So the hypotenuse must be the square root of 2. So that is root 2. Now, let's do sine 45 is opposite over hypotenuse. So that's 1 over root 2. Cos 45 is adjacent over hypotenuse, so that's the same. And tan 45 is opposite over adjacent, so 1 over 1, which of course is 1. So we've got some really important values here that we've found from those two triangles. Now there are some other values that you need to know that can't be found from those triangles, and I'll show you those now. Sine of 0 degrees is 0. Cos of 0 degrees is 1. Tan of 0 degrees is 0. Then you also need to know sine of 90 degrees, which is 1, cos of 90 degrees, which is 0, and tan of 90 degrees, we say that one is undefined. We can't find a number that's worth tan 90 degrees. So here is a recent GCSE maths question using the information that we've just learnt. You might look at it and think, I've got no idea where to start. But now you've seen those triangles, you've seen how to find cos 30, tan 60, and sine 30. It's actually quite a straightforward question. We need cos 30, we need tan 60, and we need sine 30. Cos 30 is root 3 over 2, and that is multiplying tan 60 degrees. Tan 60 is simply root 3, and then we're going to add sine 30, which is a half. Let's do the multiplying part first. So we've got root 3 over 2 times root 3. Now you know that the root 3 will only times the top, so root 3 times root 3 is actually 3. So that part is 3 over 2 plus a half. That gives us 4 over 2, which is, of course, 2. Now the question said, show that the value of that little string there is an integer. 2 is an integer. It's a whole number.